Welcome to Across the Globe. Today we will learn about building a simple ML project. Machine learning is a branch of artificial intelligence that creates models capable of making predictions or decisions based on data without explicit programming. To build a basic machine learning project, the process typically involves gathering relevant data, pre-processing it to make it usable for the model, selecting an appropriate model, training the model with the data, and finally evaluating its performance. For instance, in a scenario of predicting house prices based on features like square footage and location, the steps involve collecting housing data, cleaning and formatting it, choosing a regression model, training it with the data, and testing the model's accuracy in predicting house prices. Data for analysis can be sourced from diverse channels such as online datasets, application programming interfaces, APIs, or through manual data collection efforts. In Python, this data can be conveniently loaded for processing using libraries like pandas. For instance, the code snippet showcases how to import data from a CSV file into a pandas data frame for subsequent analysis. Pre-processing is a vital step in preparing data for machine learning models. It encompasses tasks like cleaning the data, managing missing values, converting categorical data into numerical format through encoding, and normalizing numeric features for consistency across different scales. One common technique in Python for scaling numeric features is using the standard scaler class from the sklearn.preprocessing module. By fitting and transforming the data with standard scaler, numeric features are standardized to have a mean of 0 and a standard deviation of 1, aiding model performance. To select an appropriate machine learning model, first identify the problem type, classification, regression, clustering. For example, use a classification model for predicting discrete categories like fraudulent or non-fraudulent transactions. Consider the dataset size. For small datasets, simpler models like logistic regression may suffice, while larger datasets benefit from more complex models like support vector machines. Popular models include linear regression for predicting continuous values, logistic regression for classification tasks, decision trees for pattern recognition, and support vector machines for both classification and regression tasks. Choose the model best suited to your problem and dataset size for optimal results. When working with machine learning models, it is essential to split our data into training and testing sets. This allows us to train the model on one part of the data and evaluate its performance on a separate, unseen portion. In Python, the train-test-split function from the sklearn.modelSelection module is commonly used for this purpose. By calling this function with our feature data x and target data y, along with specifying the test size parameter, we can split the data into training and testing sets. For instance, setting test size equals 0.2 would allocate 20% of the data to the testing set and the remaining 80% to the training set. Once the data is split, we proceed by fitting our machine learning model on the training data. This involves feeding the training features, xtrain, and corresponding target labels, ytrain, into the model to allow it to learn patterns from the data. After the model is trained, we then evaluate its performance using the testing data. By feeding the testing features, xtest, into the model and comparing the predicted outputs with the actual target labels, ytest, we can assess how well the model generalizes to unseen data. This evaluation is crucial in determining the model's effectiveness and identifying any overfitting issues. In summary, by splitting our data into training and testing sets, fitting the model on the training data, and evaluating its performance on the testing data, we can assess the model's ability to make accurate predictions on new, unseen data. When evaluating a model's performance, metrics such as accuracy, precision, recall, or mean squared error are commonly used. For instance, in Python, the accuracy score function from the sklearn.metrics module can be employed to determine the accuracy of a model's predictions. By comparing the actual labels ytest with the predicted labels ypred on a test set xtest, the accuracy score is calculated and can provide insights into how well the model is performing. This metric is valuable in scenarios where correctly identifying positive instances is essential, like in medical diagnostics or fraud detection. Building a simple ML project is like following a recipe to bake a cake. Just as following step-by-step instructions in a recipe helps you create a delicious cake, following the process in building a simple ML project helps you successfully create a predictive model. Gathering data is like gathering ingredients for the cake. You need the right components to get started. Pre-processing the data is like preparing the ingredients. You need to clean and sort them properly for best results. Choosing a model is like selecting a baking technique. You need to choose the right approach for the desired outcome. Training the model is like putting the cake in the oven. You need to give it time to learn and improve. Evaluating the model is like tasting the cake to see if it's done. You need to assess its performance and adjust as needed. Deploying the model is like presenting the finished cake to others. You need to share your work and the results of your efforts. Hey, Code Conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The Python code showcased here demonstrates the process of creating a basic machine learning project, likened to baking a cake. To gather the data, the iris dataset is loaded using pandas and scikit-learn. The dataset is partitioned into features, x, and target variable, y. The next step involves preparing the data by splitting it into training and testing sets and standardizing the features using a standard scaler. This is akin to cleaning and organizing the ingredients for the cake. For selecting a model, a random forest classifier is chosen in this case, which acts as the baking technique for our ML project. Following this, the model is trained on the training data, equivalent to putting the cake in the oven to bake. Subsequently, the model's performance is evaluated using accuracy as the metric, similar to tasting the cake to determine its readiness. Finally, the trained model is deployed and saved as a joblib file for future use or deployment, symbolizing the presentation of the finished cake to others. This ML project is specifically tailored to the iris dataset to predict the species of iris flowers using a random forest classifier. The model's accuracy is assessed, and the model is stored for potential deployment scenarios. This code can be extended and adapted for various real-world applications, such as species classification in botany, spam detection in emails, or sentiment analysis in customer reviews. One industrial application of building a simple ML project like this could be in the manufacturing industry. Companies can use machine learning to predict equipment failures based on sensor data. By following similar steps to gather data, pre-process it, choose a model, train, evaluate, and deploy it, they can create a predictive maintenance system. This system can help prevent unexpected downtime, reduce maintenance costs, and optimize equipment performance. Another real-world example could be in the healthcare industry. Hospitals can utilize machine learning to predict patient diagnoses based on medical data. By following the steps outlined in the example, they can build a classification model to assist doctors in diagnosing diseases more accurately and quickly. This can lead to better patient outcomes, personalized treatment plans, and improved overall healthcare quality. Across the globe, various industries are leveraging the power of machine learning to drive innovation, improve processes, and make data-driven decisions. By building simple ML projects, organizations can unlock valuable insights, automate tasks, and stay competitive in today's data-driven world. Keep learning, stay curious, and I'll catch you in the next video.